Okay, part 2 is just going to address this third problem on the sheet. So we're also going to use side angle side for this one. And we've got a couple different pieces of information here. So we've got the information that PN bisects MO. So this segment right here bisects the segment MO. So I can tell right now that I'm going to have some congruent pieces in MN and NO, but nobody has told me that yet. So I'm going to have to do that through my proof. I'm going to have to talk about segment MN being congruent to segment NO. Now I did those in yellow because I don't want to confuse it with anything the book has given me, but that's going to be one of the things I have to work with. The other thing I know is that PN, whoops, to get my highlighter instead of my pen, PN and MO are perpendicular. So I've got this sort of angle sitting here, and I know then that I've got some 90-degree angles to work with. So with 90-degree angles, it's like we all understand if there's perpendicular lines that there will be 90-degree angles, but there's another thing that I'm going to have to work through and prove in my proof. So it's not going to be super complicated, but nothing is really given to me right away that's super helpful. So I'm going to kind of go side angle side, just like we did before, and I'm going to begin with the first given, which has to do with that bisecting, and I'm going to work my way to side angle side. So I'm going to do my once again, use the wrong tool. I'm going to start with my statements on the left and my reasons on the right. And on the left, the first thing I'm going to do is start with that given, which is that segment PN bisects segment MO. Okay. And that is a given, so that's my reason. Now, because of that, what I'm allowed to say is that segment MN, segment Minnesota, is congruent to segment NO. And that is the definition of a bisector, one of the first things you learned. A definition of a bisector, a segment bisector, is that it divides it into two congruent pieces. So now, if in the last two, we kind of went side angle side in that order. So let's start talking about the angles. And we know that we have two 90-degree angles, but we have to work our way there and talk about, we actually don't have to get into 90 degrees because nowhere here do we have to get into measurements. We're only dealing with congruence. So we want to establish that we know that PN is perpendicular to MO. That was a given piece. And then we want to establish that we know that because of that perpendicular setup, there are now two right angles that we want to name. And so what we're going to do is we're going to name angle PNM, whoops, that didn't come out as clearly as I wanted it to, is a right angle, and angle PNO is a right angle. And we're allowed to say that because of, I'm going to kind of group these together, the definition of perpendicular. The definition of perpendicular says that it forms two right angles. Okay, so now we've got two right angles, but what we haven't proven is that they're congruent to each other. Now, it seems a little bit silly that you would have to say that. If we all know they're both right angles, we know they're congruent. But I'm going to go back, and if you look at your Chapter 2 list, on the newer list of theorems and postulates that you were given, there's one Theorem 263, the right angle congruence theorem. That is the one that you are want to use. Otherwise, you have to get into the 90 degree and the measurement piece and then label them congruent and go back again. A shortcut to being able to say that they're congruent to each other is to say that angle PNM is congruent to angle PNO because of the right angle congruence theorem. And all that theorem says in a nutshell is that any right angle is congruent to another right angle without having to get into its actual measurement length and having to transfer to measurement and back again to congruence. So it's a really helpful one. So now, so far, if we go through, we have established that we've got one corresponding side that is congruent, one corresponding angle that is congruent. Now we have to deal with another side. And we have to make sure that we are talking about an included angle. So the next side that makes sense is the one that is the easiest to talk about. And that is that PN, which is the segment that provides a side to the first triangle and the second triangle, is congruent to PN. And there's that reflexive property of congruence again, where the one side is congruent to itself. And now last, we're able to say, whoops, I guess I saved that for the wrong side. We're able to say that triangle, once again, paying attention to the order in which we're saying things. For me, sometimes it's easiest to start with this one right here and go M, N, P. We want to say that triangle M, N, P is congruent to triangle. Now we have to go back and make sure we do the same order. O, N, P. And that was my side, angle, side. So there it is. There are 3 examples of some proofs you can do with side, 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 and actually mostly side, angle, side. Go ahead and start your homework for today, and we will continue practicing tomorrow as well.